Fine. Today, let us discuss about that is chapter that is haloalkanes and haloarenes. So this is the that is first chapter in the organic chemistry of second year. So this halogen derivatives. From this also you will get that is questions for NEET as well as CET examination. Right. So here let us go to the introduction of this what is meant by haloalkanes and what is meant by haloarenes. So here, first let us see the halogen derivatives. So you see the halogen derivatives here. So here, what are the halogen derivatives we have? Okay, halogen derivatives. If carbon, the halogen is, if halogen is attached to carbon, which is sp3 hybridized, and there are some other systems in which halogen is attached to carbon, in which the carbon is sp2 hybridized. Okay, these halogen derivatives are generally classified into two types. One is the halogen attached to carbon, that carbon is having sp3 hybridization. Other is the halogen is attached to carbon, which is sp2 hybridized. Right. So here, let us again this is classified. Again, it is further classified into three types. In which the halogen, which is attached to carbon, which is sp3 hybridized, is further classified into three types. One, we are calling it as allylic. Next, we are calling it as alkyl. Next, we are calling it as benzylic. Right. So here, what is meant by allylic? Allylic means you can see in the that is image. You can see here. So this type of system we are calling it as allylic system. In allylic system, the halogen is attached to carbon. That carbon is attached to the sp2 carbon. That carbon is attached to the sp2 carbon. Example, you can see the example here. This is the example for that. Right. See here, this is the carbon. To this carbon, halogen is attached. This carbon is attached to the sp2 carbon. Right. This is allylic. Next one is alkyl. In alkyl also the same case. So here the halogen is attached to which carbon? sp3 carbon. Here also you can see the halogen is attached to which carbon? sp3 carbon. In allylic also the halogen attached to sp3 carbon. In alkyl also the halogen is attached to sp3 carbon. Coming to benzylic. Right. In benzylic also here you can see this is we are calling it as benzyl. C6H5CH2. Okay, this we are calling it as benzyl group. Okay, so in benzylic also you can see this is halogen. This halogen is attached to which carbon? sp3 carbon. Okay, so this we are calling it as benzyl. Okay, so this is the classification under sp3 hybridized carbon and halogen bond. sp3 hybridized carbon and halogen bond. So under sp3 hybridized carbon and halogen bond, this halogen compounds are divided into three types: allylic, okay, alkyl, next benzylic. Next, let us go for the second type of classification. This is second classification. This is first classification. In second classification, you can see the carbon is the halogen is attached to carbon, which is having the hybridization sp2. Which is having the hybridization sp2. Under this, again, this is classified. This system again is classified in two types. One we are calling it as vinylic, other we are calling it as aryl. What is vinylic? In vinylic is nothing but so this we are calling it as vinyl group. CH2 double bond CH, this we are calling it as vinyl group. Fine. So here the halogen is attached to the that is vinyl group. The halogen is attached to the vinyl group. CH2 double bond CH, Cl. Okay. So this we are calling it as vinylic group. Here you can see the halogen is attached to carbon, which is having the hybridization sp2. Next, aryl. What is aryl? Here the halogen is directly attached to the carbon atom of aromatic ring. This we are calling it as aryl. So aryl means, so this we are calling example. Okay, here I will show you. Okay, here this is aryl group. Okay, so here the halogen is attached to the that is sp2 carbon. So this is the halogen. Okay, this halogen is attached to the carbon. This carbon is having the hybridization sp2. Right. Okay, so this is a classification of the halogen derivatives. Halogen derivatives are broadly classified into two types. One is sp3 hybridized carbon halogen bond. Other is sp2 hybridized carbon halogen bond. Under sp3 hybridized carbon halogen bond, it is further classified into three types: allylic, okay, next alkyl, next benzylic. And coming to that is uh, halogen attached to sp2 hybridized carbon. Again, it is classified into two types, that is vinylic as well as aryl. Okay, so this is the classification of the halogen derivatives. Next, let us go for the next screen share. Okay, next, so we have gone through that is classification. Now it is the time for preparation of the that is our haloalkanes. How the haloalkanes are prepared. Okay, so preparation of the haloalkanes. So how the haloalkanes are prepared. These haloalkanes are prepared by, that is, you can see I have given that is there are, I have listed 5 methods. One is direct halogenation of alkanes, addition of HX to alkenes from alcohols, from Hunsdiecker reaction, from Finkelstein reaction. By 5 methods we can prepare the that is this uh, haloalkanes. Right. Now let us go for the one by one method. Okay. So first here, if you see this one, first direct halogenation of alkanes. In this it will follows which mechanism? It will follows free radical mechanism. Okay, so in this that is direct halogenation of alkanes. The alkane is treated with the halogen. The alkane is treated with the halogen. So thereby, in the presence of that is sunlight. So thereby, what you are going to get in the place of X? What you are going to get in the place of X H? We are going to get X. Okay, in the place of H, we are going to get the X. Right. Next, let us go for that is reactivity order. Here you can see the reactivity order. So allylic alkanes are more reactive. Okay. Next tertiary, followed by secondary, followed by primary, next followed by methane. So here in this reaction, what they are saying here, that is so. But in direct halogenation of alkanes is following the order. Allylic is more reactive. That means in allylic halogenation will takes place very easily compared to tertiary alkanes, followed by secondary alkanes, followed by primary alkanes, followed by methane. So this is the direct halogenation of the alkanes. Right. Next, so this is the order we are going to get. In direct halogenation of alkanes, what we are doing? Simply we are taking alkane and we are treating with the halogen in the presence of the sunlight. In the place of H, what we are going to get? We are going to get that is halogen, and we are going to get alkyl halide. Next one is addition of hydrogen halide to alkenes. So from that is we have prepared uh, from alkanes. Now let us go for the preparation. Okay, so prepare from alkenes. So here alkyl halides. So here I will draw this one. This alkyl halides, it can be prepared. These alkyl halides, it can be prepared from other organic compounds. So here, this alkyl halides we can prepare from alkanes. This alkyl halides we can prepare from the this alkyl halides we can prepare from the alkanes. Next, we can prepare from the alkenes. So alkyl halides, right? It can be prepared from. So in the examination, they will ask which are the following methods. By which of the following methods alkyl halides can be prepared. So alkyl halides we can prepare from alkanes. It can be prepared from the alkanes. It can be prepared from the alkenes. It can be prepared from the alcohols, right? It can be prepared from that is a named reaction called that is Hunsdiecker reaction, and it can be prepared from that is one more named reaction called that is Finkelstein reaction. From these 5 methods, we can prepare the alkyl halides. From alkanes, how we are preparing alkyl halides means by direct halogenation. Okay. So by which method? By direct halogenation. Okay. So by direct halogenation, we can prepare. Okay, from alkenes, how we can prepare? We can prepare by that is addition of HX. By addition of HX, we can prepare this one. From addition of HX, we can prepare. Next, we can prepare from alcohols by that is by reaction with that is halides. By reaction with the that is halides, hydrogen halides. By reaction with the hydrogen halides. And in Hunsdieck reaction by bromination, and in Finkelstein reaction also we can prepare. Okay, let us discuss one by one. So already we have discussed this. Next, in addition of hydrogen halides to alkenes. So in this, what we are taking an alkene. Okay, and we are doing making react with the hydrogen halide HBr. Okay, this hydrogen is added to this carbon and this bromine is added to this carbon, and double bond is converted into single bond in addition reactions. And thereby, what you are going to get upon addition of hydrogen, CH2 will convert to CH3, and we are going to get this one CH3 CH2 Br. Okay, so we are going to get this compound. Fine. So if you are taking the peroxide, unsymmetrical alkene, if you are taking means it will follow rule. CH3, CH double bond CH2. I am taking an unsymmetrical alkene called propene. Right. This propane upon addition with the HBr. What happens? So under no catalyst, no peroxide catalyst. So here this hydrogen will goes to the carbon where carbon is having more number of hydrogens and bromine will attach to this carbon. And thereby what you are going to get here? CH3, CH that is CHBr, CH3. Suppose this you are taking same propene, you are taking the same propene and you are doing addition with HBr in the presence of peroxide catalyst. So in this case, what happens? This hydrogen will goes to the that is carbon where carbon is having less number of hydrogens, and this bromine will attach to this carbon. Reverse. This we are calling it as anti-moriconic of CH3, CH2, CH2Br. So anti-moriconic of we are going to get primary alkyl halide, right? In Markovnikov, we are going to get secondary alkyl halide. This is the that is addition of HX to alkenes. Next from and it will follow the reactivity order. So in this hydrogen halides, if you are doing the reaction with HI is more reactive compared to that is HBr. HBr is more reactive compared to HCl. HCl is more reactive compared to HO. So this is the order, right? Next, so this is that means hydrogen iodide is it can add across the alkene very fast compared to HBr. HBr can add to alkenes very fast compared to HCl. HCl can add to alkenes very fast compared to HF. Next from alcohols. Next we will go for the third one, that is from alcohols. From alcohols, how will you prepare? So from alcohols we are taking that is alcohols are treated with the phosphorus halides PX3. Okay, 3ROH plus PX3. So in the place of OH, what you are going to get? X will be attached. Thereby what you are going to get? You are going to get alkyl halide. Next, you are going to get H3PO3. Okay, so 3 moles of alcohol you take and you treat with the phosphorus halide. Okay, like phosphorus halides are of two types. One is phosphorus trihalide, one is phosphorus pentahalide. Okay, both it can show. So PX, so this is phosphorus trihalide. So I am taking an alcohol and I am making to react with phosphorus trihalide and we are going to get this alcohol. Next, you take alcohol and you treat with the HX, hydrogen halide. What you are going to get in the place of that is OH, X will be joined, H will be substituted, and thereby what you are going to get RX plus H2O will be eliminated like this, RX plus H2. Next, alcohol you take and you treat with the thionyl chloride, SOCl to what we are calling it as thionyl chloride. So among this is the best preparation. So in the examination, they will ask which is the best method for preparation of alkyl halides from alcohols. Okay, so this is the best method. Alcohol upon treatment with thionyl chloride. So they asked it in the previous year questions also. So this is the best method for preparation of the alkyl halide from alcohol. Why? I will say here. So when you are taking alcohol and upon you are treating with reaction with the thionyl chloride, what you are going to get? You are going to get that is the place of OHCl will going to get, and SO2 gas will be avoid and HCl, and you are going to get alkyl chloride, right? So among this, why this is the best method means because here you see the byproducts. Byproducts SO2 and HCl both are gases, so it can easily evaporate, thereby leaving behind the main product. That means in this reaction, there is no need to separate the main product from byproducts. The byproducts being gases, it easily escapes from the reaction and thereby leaving behind the product. So that is the reason this is the best method for preparation of alcohol from alkyl chloride. So very important. So above methods also we can prepare, but here what happens is we have to separate the byproduct from the main product. But in this reaction, no need to separate the byproduct from the main product. Okay, because the byproducts itself are gases, it easily escapes. Next one is Hunsdiker reaction. Okay, next fourth one, let us go for the fourth one, that is Hunsdiker reaction. In this, what we are taking means we are taking, that is silver carboxylate, a salt of carboxylic acid. It is silver carboxylate. This one. What is the name of this salt? Silver carboxylate. This silver carboxylate, upon treatment with bromine, in the presence of carbon tetrachloride, okay, and followed by reflux. So what you are going to get? You are going to get alkyl bromide, RBr, plus CO2 plus AgBr. So you are going to get this product. So here, upon treatment of silver carboxylate with bromine, in the presence of CCl4, we are going to get alkyl halide, that is, and alkyl bromide, you are going to get CO2 and AgBr. And one more reaction is there, that is Finkelstein reaction. This is Finkelstein reaction, the last one, that is, we are calling it as halogen exchange reaction. Finkelstein reaction, we are calling this as halogen exchange reaction. What is this Finkelstein reaction? In Finkelstein reaction, we are taking an alkyl halide and we are treated with the sodium iodide in the presence of dry acetone. Dry acetone. So what we are taking? We are taking an alkyl halide. We are taking an alkyl halide and we are treating the sodium iodide. That means here, this is an halogen exchange reaction. Finkelstein reaction comes under halogen exchange reaction. Halogen exchange reaction. So in this, what happens is in the place of halogen X, iodine will be substituted, and thereby what you are going to get? Alkyl halide Ri plus NaX. You are going to get this one. Okay, alkyl halide plus NaX. So this is one halogen is here X is equals to that is chlorine and bromine. Okay, so here in the place of other halogen, in the place of chlorine or bromine, iodine will be substituted. One halogen is substituted by other halogen. One halogen is substituted by other halogen. That's why this reaction comes under the halogen exchange reaction, Finkelstein reaction. Okay, so this is about preparation. Next, let us go for the properties. Okay, next we'll go for the properties. So chemical properties. So here you can see the chemical properties. So these alkyl halides will undergo three types of reactions. One is we are calling it as elimination reaction. Other is nucleophilic substitution reactions it undergo. And apart from elimination nucleophilic substitution reactions, alkyl halide will show some other special reactions that we are calling it as miscellaneous reactions. Right. So alkyl halides will undergo how many types of reactions? Three types of reactions. First is elimination type of reaction. Next one is nucleophilic substitution. Next one is, last one is a special type of reactions that we are calling it as miscellaneous reactions. Right. Here nucleophilic substitution reactions. First let us discuss about the nucleophilic substitution reaction. And let us go for the, that is first type of reactions called elimination reactions. So elimination reactions, so alkyl halides will undergo elimination reactions by dehydrohalogenation as well as by action of heat. Right. So here alkyl halide, when you are treating with the alcoholic KOH, when you are treating with the alcoholic KOH, remember this alcoholic KOH is the strong base. What it is? Strong base. So what happens here? Halogen. Okay. So here what happens means this halogen will be moved. This halogen will be okay. this halogen, okay, this halogen will be eliminated, and here one hydrogen will be eliminated, and thereby you are going to get a double bond between these two, and you are going to get an alkene. From dehydrohalogenation, we can convert alkyl halide to alkene. Okay, we can convert an alkyl halide to alkene, right? Alkyl halide to alkene. So this, and moreover, this elimination follows the Sagehoff rule. It follows the Sagehoff rule. And ease of dehydrohalogenation. So which type of alkyl halide will undergo dehydrohalogenation easily means tertiary. Tertiary will undergo dehydrohalogenation very easily compared to secondary. Secondary will undergo dehydrohalogenation very easily compared to primary. Next, action of heat. Okay, action of heat. So in this action of heat, what we are doing, we are taking an alkyl halide. We are taking an alkyl halide, and this we are heating is 573 Kelvin. When we are heating at 573 Kelvin, what happens? Same. Halogen from this carbon and hydrogen from this carbon is eliminated, and thereby what you are going to get? You are going to get an alkene. You are going to get an alkene. Understood? Next, let us go for that is second type of reaction, that is nucleophilic substitution reaction. Okay, nucleophilic substitution reaction. So this it is of two types. One is SN1 reaction, other is SN2 type of reaction. So this is elimination type of reaction is first type, and nucleophilic is second type, and special type of reaction miscellaneous is third type. SN1 type of reaction as well as SN2 type of reaction. SN1 type of reaction, what we are calling this as, it is first order kinetics. It will follow the first order kinetics. SN1 type of reaction is okay. SN1 type of reaction, we are calling it as first order type of reaction. And the reactivity order is for SN1 type of reaction, that is tertiary is more reactive. Tertiary is more reactive compared to secondary. Secondary is more reactive compared to primary. Primary is more reactive compared to methyl halide. This is SN1 type of reaction. SN2 type of reaction, you know, that is nucleophilic, that is bimolecular nucleophilic substitution reaction. It follows second order kinetics. Which order kinetics? Second order. The reactivity is methyl halide is more reactive compared to primary, and is more reactive compared to secondary. Tertiary. Reverse. The reverse of SN1 is SN2. Okay, and here we can see this nucleophilic substitution reactions. Here we can see in this hydrolysis with alkalis. Okay, hydrolysis with alkalis. So here in nucleophilic substitution reaction, what we have, that is this in the place of X. Okay, alkyl halide we are treating with the, that is AgOH, silver hydroxide, and thereby what you are going to get? You are going to get the alcohol. You are going to get the alcohol. You are going to get. And here that means when alkyl halide is this reaction, we are calling it as hydrolysis with alkalis. Alkalis means it is which is having OH minus ions, that we are calling it as the solutions which containing OH minus ions. More number of OH minus ions, that we are calling this alkali. So here alkyl halide, when we are treating with the AgOH, we are going to alcohol. Similarly, this alkyl halide is treated with aqueous KOH. It is treated with aqueous KOH. So what you are going to get in the place of X, what you are going to get? OH you are going to get. In the place of X, OH you are going to get. So when alkyl halide is treated with AgOH as well as aqueous KOH, so in the place of halogen, what you are going to get substituted? OH is substituted. Okay, so this is the first reaction under nucleophilic substitution reaction. Next one is Williamson synthesis. Williamson's synthesis. What does this Williamson synthesis explains? Okay, so in Williamson synthesis, you take alkyl halide and you treat with the, that is sodium alkoxide in the presence of heat. So here what happens here? Halogen from this compound and sodium from this compound is eliminated. Okay, and thereby this alkyl group and this alkoxy group will join together. We are going to get ether. ROR dash. We are going to get the ether. Understood? Next, you see the third reaction under nucleophilic substitution reaction. Alkyl halide, when we are treating with the KCN, alcoholic KCN. What you are going to get? You are going to get that is halide of potassium, and you are going to get, that is nitrile, cyanides. These cyanides, okay, these cyanides on hydrolysis, on further reaction, these cyanides on hydrolysis, what you are going to get? You are going to get a compound called amide. RCONH2, we are going to get amide. Amide on hydrolysis. What you are going to get? You are going to get acid. Okay. Next, same. This cyanides upon treatment, upon reduction with sodium in the presence of methanol, upon reduction with sodium in the presence of methanol, or upon reduction with lithium aluminum hydride, the cyanides are converted to the amines. Cyanides are converted to the amines. Okay, cyanides are converted to the amines. Next, these cyanides upon treatment with SnCl2 and HCl2, SnCl2 and HCl2. What you are going to get? You are going to get imine hydrochloride. What you are going to get? Imine hydrochloride. This we are calling it. This on hydrolysis, you are going to get aldehyde. Okay, so what is the name of this reaction? You know, this reaction we are calling it as Stephan reduction. Stephan reaction. In Stephan reaction, what is the reactant? Cyanides. And what is the product? Aldehyde. Next, alkyl halide upon treatment with AgCN. Alcoholic AgCN. Alcoholic AgCN. So what happens here? Halogen from here, Ag from here is eliminated, and Cn will be joined with alkyl group, and whereby you are going to get isocyanate. You are going to get a compound called isocyanate, right? So this is chemical properties of that is chemical reactions. So we have covered elimination reactions. So alkyl halides will undergo three type of reactions. I said elimination reactions we covered, nucleophile substitution reaction SN1 and SN2, and followed by these reactions. It is also we covered here. Next, let us go for the third type of reactions that we are calling it as miscellaneous reactions. Third type of reactions, what we are calling it as miscellaneous reactions. Okay. Let us go for the third type of reaction shown by alkyl halides. Okay, this is the miscellaneous reactions which is shown by the alkyl halides. So here in miscellaneous reactions, first one is reduction. First one is reduction. Second one is Wurtz reaction. Third one is reaction with metals. House alkane synthesis, oxidation. So in reduction, what we are doing, we are taking that is we are reducing. We are doing reduction with the nickel or palladium catalyst. And thereby what happens in the place of alkyl halide, what you are going to get? In the place of halide, you are going to get H. That means alkyl halide is converted to the alkane during reduction process. In Wurtz reaction, what you are doing? We are treating with the sodium metal in the presence of the dry ether. Thereby what you are going to get? You are going to get alkane. Reaction with metals, alkyl halide upon reacts with magnesium. The presence of dry ether, what you are going to get? You are going to get Grignard reagent. You are going to get the addition reaction. This is alkyl halide is directly added to magnesium. Magnesium is directly added to the alkyl halide in the presence of dry ether. Thereby, what you are going to get? You are going to get the Grignard reagent. Next, alkyl halide upon reacts with the zinc. In the presence of ether, you are going to get dialkyl zinc plus 7x2. Okay. Next, alkyl halide upon treatment with sodium alloy, you are going to get tetraethyl. And House reaction, that is all dialkyl copper lithium we are taking. In House reaction, dialkyl copper lithium we are taking, and we are treating with the alkyl halide, and thereby what you are going to get? You are going to get that is alkane. This reaction also we are going to get alkane. Okay, oxidation. Oxidation, alkyl halide upon treatment with DMSO4, what you are going to get? Aldehyde. Next, secondary alkyl halide upon treatment with the DMSO, dimethyl sulfoxide, you are going to get ketone. Primary alkyl halide will give to aldehyde, secondary alkyl halide will give to ketone. Okay. So here in the examination, how the question will ask means here. So by how many methods? By how many methods? Which of the following methods? Which of the following methods leads to preparation of alkanes from alkyl halides? So in the examination, they will ask like this. So which of the following methods leads to preparation of alkanes from alkyl halides? So by how many methods we can prepare alkanes from alkyl halides. So alkanes can be prepared from alkyl halides by reduction. Yes, in reduction, what you can observe, the place of halogen, what you are going to get alkane. So from reduction we can prepare, and by Wood's reaction also we can prepare alkane from alkyl halides. Okay, and by Core-House synthesis also we can prepare that is alkanes from alkyl halides. Okay, so here finally, so we can prepare by three methods. So alkanes can be prepared by alkanes can be prepared from alkyl halides by three methods. One is by reduction of alkyl halides, by reduction of alkyl halides, okay, by Wood's reaction, and third one is by Core-House reaction, by Core-House reaction. So you have to please make a note. So from these three methods, we can prepare that is alkanes from alkyl halides. Okay, so alkyl halides can be converted to the alkanes. So from how many methods we can prepare? From three methods. By reduction of alkyl halides, we can prepare alkanes. From Wood's reaction also we can prepare alkanes. From Core-House reaction also we can prepare alkanes. So these are the three methods by which we can convert an alkyl halide to alkane. Right. Next, let us go further. That is important compounds of halogen compounds. What are the important compounds of halogen compounds? First one is chloroform, CHCl3. Okay. First one is chloroform. That is CHCl3. It is used as an anesthetic. It is used as an anesthetic. Okay. Due to its harmful effects. Due to its harmful effects, it is used as an anesthetic. And it is used for preparation of the compounds called chloratone and chloropicrin. So it is used for preparation of the compounds, so chloratone and chloropicrin. Chloropicrin formula CCl3 and water. Next, it is used as solvent. It is used as chloroform is used as solvent for fats and waxes. Next compound, next we will go further. That is iodoform. Okay, so iodoform also is one of the important that is halogen derivative compound. Iodoform, it is also used as a disinfectant. It is also used as disinfectant. Iodoform, it is also used as disinfectant. It is effective as chemical antiseptic. Next one, next compound we are going to discuss is freons. Freons are, we are calling it as CFC, chlorofluorocarbons. It is used as refrigerants. It is used in propellants, in aerosols, as body sprays, air sprays, and cleansers. And next compound is DDT. Next type of compound is DDT. So DDT it is used as powerful insecticide, effective against Anopheles mosquitoes. And Teflon. So this Teflon is also very important. By Teflon, it is used as non-stick coating for pans and other cookwares. Teflon is used as non-stick coating for pans and other cookwares, and it is used in containers and pipe. It is a polymer, okay, and it is used in containers and. So these are the that is use of some commercially important halogen derivatives: chloroform, iodoform, freons, DDT, and Teflon. Okay, so this is about the that is synopsis of the this chapter, that is haloalkanes and haloarenes. Next, let us go for the that is objective questions. So, what are the questions which they have given in the previous examination of this haloalkanes? Let us have a look. Okay. Okay, students. Just a minute. Fine. You do these questions. Question number 5, 6. That is 7. See the question number 5, 6, 7, 11, 12, 13, 14. Start doing these questions. Just I will give, there is 5 minutes time. Last 2 minutes, all are easy questions only. You can do very quickly this one. Okay, students, let us start answering these questions. When two halogens are attached to same carbon atom, it is known as. So, if two halogens, okay, so if two halogens are attached to same carbon, okay, this carbon, okay, we are calling it as that is this type of compound we are calling it as gem dihalide. What is the type of compound we are calling it as gem dihalide? So, option B is correct. And gamma hexane. Gamma hexane, what is gamma hexane? Benzene hexachloride. That we are calling it as BHC. That we are calling as gamma hexane. Okay. Next, the product obtained by treating. Just a minute, students. Okay. So gamma hexane, that is BHC, what we are calling it as. Next, the product obtained by reacting, that is HBr. Okay. So what you are going to get here, it is that is seventh question. If you see this one, HBr, hydrogen will be going to this carbon and there is no catalyst, so it will follow Markovnikov and Br will go to this one. And finally what you are going to get, that is option B is correct. And the reaction, that is ethanol reacts with thionyl chloride in the presence of pyridine. You are going to get ethyl chloride plus SO2 and HCl. This reaction what we are calling it as, okay, this reaction we are calling it as that is Dargen's reaction. Dargen's reaction. Next, which of the following is most stable? So which of the following is most stable among this one? It is 2-butene. 2-butene is most stable because it is the double bond is substituted in the middle. So you can see 2-butene, CH3, CH, double bond, CH, CH3. Okay, this is highly substituted double bond. 1-butene is less substituted double bond and 2-butene is highly substituted double bond. Okay, so here this double bond, so you can see the alkyl groups has been substituted in the place of hydrogen. So this is highly substituted, so it is more stable. Highly substituted double bonds are more stable. So highly substituted double bonds are more stable. Double bonds are more stable. Okay, substituted double bonds are highly substituted. That is double bonds are most. Next one, among the following, the most reactive towards alcoholic KOH. So which is more reactive towards alcoholic KOH? So here it is not. So here there is no elimination. Alcoholic KOH means which type of reaction to undergo? Elimination reaction. Elimination reaction. First compound won't undergo elimination reaction. Second will undergo elimination. Third will undergo elimination. Fourth will undergo elimination. This will undergo elimination. This will undergo elimination. This will undergo elimination. So among these three, which is more reactive towards alcoholic KOH means it depends upon the product formed upon reaction with alcoholic KOH. If the product formed upon reaction with alcoholic KOH is more stable, that one is more reactive. Let us see what is the product formed by the B. Okay, what is the product formed by the B? So here, if you are taking this, the compound B, it is having the formula that is CH3, okay, C double bond O, next to CH2, next CH2 Br. So this upon treatment with this compound upon treatment with alcoholic KOH, this compound upon treatment with alcoholic KOH, what happens? So hydrogen from here, Br from here will be eliminated, and thereby you are going to get a double bond here. So what you are going to get CH3, C double bond O, next CH double bond CH2. So now you can see there exists a conjugation. Okay, so this is a conjugated compound. Why means here you can see a double bond and here also you can see a double bond. So this is a conjugated compound. The conjugated compound is more stable compound. So here, and it won't form any conjugated compound. Upon treatment with alcoholic KOH, what is the compound formed by this one? Upon treatment with alcoholic KOH, you are going to get that is ethene. What you are going to get? Ethene. So here it is also we are going to get propene. No conjugation in D and no conjugation in C. Only conjugation in B. The conjugation products are more stable. So option B is correct. So 14th one, among the following, the dissociation constant is highest for. Dissociation constant they are asking. Dissociation constant means, so here all the compounds are acidic compounds. All the compounds are acidic compounds. Okay. So here, and A, B and C, compound A, compound B and compound C are covalent compounds. Covalent compounds. Covalent compounds won't undergo dissociation. And D is, this compound is an ionic compound. Ionic compound will undergo dissociation on heating. It will break. Ionic compound will dissociate into two parts upon heating. So option D is correct. Okay, next let us go for the next screen share. Next screen share. Next set of problems. Just a minute. You see this one. Question number 1, 2, 3, 4, 9, 10. This you take screenshot. We will go for a set of problems. This you can do by yourself because these are somewhat easy. Please take the screenshot, students. Okay, we will. You can practice. We can go for the other set of questions. Please take the screenshot. Next, we'll go for the set of questions. Right. Yes. This. You see. Question number 16, 17, 21, and 22. Please have a look for a minute. Okay. Let us go for the, that is solving this one. So first one, the correct increasing order of the reactivity halides for SN1 reaction. For SN1 reaction. So here they have given that is four options. In these four options, you can see four compounds. So alkyl halide, primary halide, secondary. This is secondary. This one is primary. This is which type of alkyl halide? This is allyl type of alkyl halide, and this is which type of alkyl halide? Benzyl type of alkyl halide. Right. The correct increasing order of the reactions, reactivity of SN1 type of reactions. So here, if you see this one, that means option A. If you check the option A, that is CH3, okay, CH2, X is there. So this upon undergoing, so it will form which carbocation? Primary carbocation, CH3, CH2, plus. Okay, which is less stable. It is primary carbocation is less stable, very less stable. Next, secondary carbocation. So this compound is CH3 twice CHX. This upon cleavage, what you are going to get? Secondary carbocation. You are going to get the secondary carbocation. This is somewhat okay. And allyl carbocation, we will get this one. This upon breaking, what you are going to get? Allyl carbocation. CH2 double bond CH, CH2 plus. This positive charge will be stabilized by this shifting of the pi bond. Next, and we have that is benzyl carbocation we are going to get. EHCH2 plus. Benzyl carbocation is more stable. This is more stable. After this, allyl carbocation. After this, secondary. After this, that is primary. So first, this one is more stable. Second, this is allyl carbocation. Second is more stable. Next, afterwards, third one. This is third is more stable. Second, this is third. Okay, I will write. So among this, which is more stable means this is first. First we will go to first this one. Next, second more stable. First more stable. Second more stable. This is third more stable, and this is fourth more stable. So it will follow like this: 4 less than 3 less than 2 less than 1. So which option is correct? Option A is correct. Okay, 17th one, that is which of the following compounds has the highest boiling point? So highest boiling point, you know that boiling point will depends upon the which factor? The boiling point will depends upon the that is it depends upon the surface area. Boiling point is directly proportional to the that is surface area. Boiling point is directly proportional to the surface area. More the surface area. So more the surface area. Okay. So more the surface area, we are going to get more the surface area, more will be the boiling point. So among this option A, option B, option C, and option D, which is having more surface area. So no branching is there. So this is having more surface area. Right. So this is having the more boiling point. 17 option B is correct. Right. Next, coming to this one. Okay. So this is a 3-carbon chain only. Don't think this is a 4-carbon chain. So they made it for confusion. This is 3-carbon chain only. 1, 2, 3, and this is substituent. CH3 substituent. This is 4-carbon chain. So this is having more surface area. This is having the more surface area. So more surface area means more boiling point. So option B is correct in this case. Next, 21st question. So here, what they are asking, C8H16 that can form cis-trans geometrical isomerisms. So what is the condition for a compound, for an alkene to undergo cis and trans isomerism? So it should have, that is two same groups like this. A. So if a compound is having groups like this, A, B, okay, D and A, yes, it will follow. It will show cis and trans isomerism. Why? Means because it is having the two same groups, A and A. Now this is which configuration? Trans. If you that is, if you shift this up and if you shift down, what you are going to get? You are going to get the cis configuration. Okay. This is cis configuration. So it will undergo cis and trans configuration. Now among this, which will undergo cis and trans configuration? So if you observe carefully, so which will undergo cis and which will undergo trans configuration. So here, if you take this is the alkene, so it is having the CH3 here and it is having H. This is CH3 and this will be H and this is CH3 and this will be that is other group C2H5. Two same groups are there now, CH3, CH3. Yes, it will undergo that is cis and trans. Coming to B, so you see here it is having hydrogen. So so for this carbon C2H5, this group is C2H5. This group is H, and for this carbon, okay, this is CH3, and this is also CH3. So different group, not CH3. This is some secondary alkyl group they have given. Okay, so here what we have here, this is C2H5H, and this side CH3 and secondary alkyl. Four different groups are there. So it won't undergo that is cis and trans configuration. So the correct option is option A. Next, coming to 22nd question. So that is, if you take this compound, 22nd compound, so among this CH3 double bond CH3H3, so NOBr, we are adding NOBr. When we are adding NOBr, so NO is having which charge? So it is having, that is, NO will be having minus charge. NO, Br is having plus. Br is having plus. NO Br, we are adding to this one. NO minus and Br minus, or NO plus and Br minus, NOCl, NOCl, CBr. Okay. CH3 Br will be added to the substituent and NO plus. Okay, NO plus we will take, and here we will take Br minus. Okay, this I will tell later. Okay, 22nd I will tell later. Okay, so this is um, okay. Okay, students. So this is today's class. Let us go. So I am leaving the session. Okay, you have other class right now. Okay, I am leaving the meeting, students. Any doubts? Okay, no problem.